Welcome to the meetup for Argo, and really happy to have you here. We've got a really cool speaker. Nick is joining us from Google. Nick, you want to introduce yourself?
Sure. Happy Tuesday, y'all. My name is Nick Ebert. I'm a product manager working with GKE at Google, and I'm here to talk to you today about having sort of a fleet of fungible clusters, and give some live demos, and hopefully, they go off without a hitch.
Fantastic. And I'll be playing moderator today. My name is Dan Garfield. I'm the Chief Open Source Officer and co-founder of CodeFresh. You can follow me on Twitter at @todayWasAwesome. I'll throw that in the chat. The way that we like to do these meetups is typically we like to have lots of conversation, lots of participation. So I see people are already in the chat. They're saying, hey, we're running a couple of clusters. I want to run a bunch of clusters. They're saying I'm new to ArgoCD. Some people are saying, hey, I'm hanging out in Egypt. I see you, Ahmed. Thanks for joining. So all of you, as you join, please keep the comments going, keep the conversation going. Throw the link to the meetup on Twitter and social media. Tell people that you're hanging out right now. We'd love to have more people join. And then as we go, feel free to use the Q&A box. And I think, Nick, we'll probably do Q&A at the end, I think is what we have planned. But if you interrupt yourself to take Q&A, I wouldn't stop you either.
Yeah, the more back and forth I think the better it is for all parties involved. Yeah.
Perfect. All right. Well, I will stop standing in the way of our speaker, Nick. And Nick, the floor is yours.
I appreciate that. Well, first of all, thank you everyone who's joined. This is a really exciting topic for me. I started my journey with Argo probably about 4 years ago, maybe 3.5 years ago, and then took a long break when I joined Google. And over the summer, I was deciding, hey, I don't really see as much information about running Argo CD or rollouts on GCP as I'd like to see. So it was kind of like a personal mission of mine to go out there and try to build an environment, a platform on top of Argo CD using GKE and some of the fleet features that comes along with it. So it was really fun for me. I ended up building a pretty interesting demo. I'll share it with y'all. It's embedded in the deck. It's on GitHub. It's out there, and I learned a lot. So this is my opinion on how I might build it. I put some thought into it, but it's certainly not the only way to do things. So if you have some pointers or some good ideas about how I can improve or corrections to make, please do so. So we're talking about fungible clusters, right? And we're talking about sort of an abstraction, I think, and having an abstraction over a slew of clusters without having to give up the freedom of the open source Kubernetes API. So you know how GitOps works. You're part of this amazing meetup group, so I assume you know Argo CD. But the idea here is that you're going to use as many components that can be composed in the Kubernetes resource model, post them to a Git repo, and then add and remove clusters as you need. And then based on the tags or labels that you give these clusters, they'll come up to state in a way that makes them immediately production ready. And that was kind of my idea. I wanted to prove that I could do this really well with Argo CD using GKE features. Sorry. There we go. So I like to start off with sort of like a customer user journey, a CUJ. And the one that I typically kind of think about as I'm coming to this conclusion that maybe fungible clusters is a good idea is like, right now I'm being asked to support apps from one region, but I know that'll change in the future. So you're a new business and maybe you're just stepping into containers, or you're building a platform and your applications are all hot in one region because you've got some legacy relational database, or not legacy, you haven't defeated the cat theorem to have a ACID semantic transaction database that's hot in two different regions at the same time. But you do think that maybe you'll start to shard or solve those problems later. As your business grows, you might need to add more regions in. So how do you build for what you have today while making it super easy to add clusters in other regions as your demand from your application owners or your business unit grows? So I think that's one pretty compelling CUJ. And then the other one is that there are some features, and it's not just GKE, it's AKS, it's EKS, it's OpenShift. But there are some features that are immutable when you're launching a cluster, right? And there's some things that you make decisions about, and something new comes out sometime later, and you have to spend some time trying to unravel that decision that you made earlier so that you could have this new feature, because you can't just add it to the cluster that already exists, is my point, right? And so if you treat clusters as a pattern, if you will, the idea here is that you could just promote a cluster in, fail workover, canary release workover to that cluster in the same region right next to it, to the other one. And then, once you've proved that the new cluster, the new feature works, and you have a confidence in the new cluster, you could shut down the old one. So like, these are two pretty compelling reasons for having these patterns of just adding and removing clusters based on either business demand or some sort of technology feature that you're after. So what do you need to sort of build this platform on top of ArgoCD and or Kubernetes, I should say? I try to look at it with these kind of components. This is not set in stone. This just helps me sort of think about the problems and the interfaces between the different pieces of the solution, right? So on the bottom layer, you've got infrastructure. In this case, it's basically, the networking, security features, IAM stuff, all the things that you would probably deploy using Terraform or cross-plane IO or bash scripts, maybe, I don't know, right? So that's all the stuff that you're baking in at the infrastructure. And then on top of that, you have sort of like this fleet controller configs, which I would say is a set of configurations that you're dedicating to probably a cluster. You don't always need one, but with ArgoCD you do. So it would be this controller that's looking and watching for things that only needs to run in sort of like a tooling cluster that provides services to your fleet of clusters, of application clusters. And then you have your application clusters, which have, whatever production tool chain that you need installed on it. Maybe you're using, maybe you're doing some like container scanning, some proprietary stuff. You got a logging agent, a slew of network policies, security policies, things like that. All those things can bake into the application cluster config and be stored in a repo as well. And then the top layer here is sort of the interface between that team, or those people that are providing a way for their developers to sort of consume this platform, if you will. And this is, I think, would be made up of, depending on your business, so it would change, but in my made up fictional business that I'm talking about here, I'd probably have a business unit, which might be a team. And within that team, I might have a number of services, and each of those services would be namespaced, right? So like a team will have multiple services. There's a namespace that they get wrapped. Is it stuck on the Spider-Man image?
Huh. Yes, it is stuck
Sorry
on the Spider-Man image. I thought that was on purpose.
Let me see if I can reshare. Is that better? Okay, I think it is.
Yeah, that's working better. Thank you.
Yeah, sorry about that. So this is what I've been talking about for the past 3.5 minutes, maybe longer. But on this top layer, it's this sort of aggregation of resources that make up an application and the human beings that interact with that application. So whether it be setting quotas, HPAs, deployment services, you're probably going to need that with some separation between your teams if you're planning to do a multi-tenant fleet where you've got multiple business units with multiple services in each one's kind of living on the same bunch of clusters. This also works too if you wanted to have smaller fleets, if you will, and use cluster as an isolation mechanism. But for the purposes of this talk, I'm just going to assume that we're multi-tenanting. All right, let me just make sure the slide changes. Yes, it did. All right. So we went over this, right? So, but it's kind of interesting to point out that as I was building this, I realized that sort of each boundary, each one of these boxes is serving a UX persona. Where on the top of the team, you're serving your app developers that are writing business code, right? And then the infrastructure folks in the bottom are probably building infrastructure as code, so another set of developers probably. And then the people who are figuring out how to build the patterns of KRM are sitting in the middle. Then we went over this. So at the fleet layer, there's some things that I think you have to consider if you're going to start to use fungible clusters, right? You probably need some sort of networking tier that's going to allow you to add a cluster to a load balancer, external or internal. And then once it comes online, the load balancer itself recognizes that the services running in that cluster are part of the same services that it should be exposing with a particular route or path, right? And then you also probably want some redundancy so that some high availability, not only across multiple clusters, so you can have a load balancer that's distributing traffic to the users in the east to an East Coast cluster and users in the west to a West Coast cluster. But you probably want to have maybe some failover between services within the clusters. And the way that you could do that is by sort of establishing service sameness, if you will, and using maybe a service mesh. There's other ways to do it too, but basically service A calls service B, tries locally. If service B is down, then it'll go to another cluster. And you can have sort of an ordered preference, right? Another thing you want to solve for is identity, the identity of your workloads. You probably don't want to be individually managing the identity per cluster. So then if you have like 10 clusters and your services across those 10 clusters, you don't want each cluster to have a unique identity. You'd probably rather manage it's sort of a workload identity that gets bound to any cluster that's using the Kubernetes service account. And then, of course, we've got this configuration requirement, I think, right? So this is where GitOps comes in. It simplifies sort of your management. It gives you the ability to manage multiple clusters from a central location, which is very useful. And then when you're building out your application tier that you're providing to your teams, you probably want to have some sort of dry templating mechanism, whether it be Customize or Helm, or again, bash scripts, whatever works. Yeah, and then what are you providing this team that's on top, right? This is where it's interesting. Not every application can support this, but it would be good to provide them a way to progressively roll out. And not just a way to progressively roll out. What I mean by progressive, like step in some sort of weight of requests to distribute across to your new version, test it, make sure it's working, and then step up the weight of traffic that's going to the new version until eventually all traffic's going to the new version. But not only to sort of do that within one cluster, but maybe to do that across multiple clusters, and maybe assign waves to each cluster so that you can progressively release to wave 1. And then, so every cluster that's tagged wave 1 can receive these, the new version, and progressively receive that new version. And then once there's consensus that's worked, maybe you put a manual gate that then allows you to release it to wave 2, etc., wave 3 if there needs to be. So we think that maybe you want to not only roll out progressively to one cluster, one set of clusters, but maybe across multiple clusters. So there's tiers of it. So how did I solve that as I was trying to like build this platform, this example of a platform? Well, I'm partial to customize, so I built a package for generic applications and customize, and then I have, if you're familiar, you have layers of configuration, and so I use customize to build layers so that I could just onboard an application with a quick bash script if I give it a couple of variables. Partial to bash when I'm trying to build things quickly. There's probably a better way to do it. Maybe I would, if I was doing it for reals, I'd probably write like a Go CLI or something. But and then the application cluster is, the application clusters are basically completely staged and ready to go in the Argo CD sync, the repo that Argo CD is syncing to, as well as the fleet controller. So the application clusters, I'm using ASM here, which is a service mesh, and I'm exposing all the applications with a gateway. And so one of the things that gets baked whenever I add an application cluster is a new gateway, right? And that gateway is then controlled by what Google GKE provides, a MultiCluster Ingress controller for load balancers. And what that means is I can have a single controller influencing change over a single load balancer whose backend has a number of clusters. And then based on the route rules and the way that I program that load balancer, user traffic will flow through the load balancer and get distributed to a cluster that that particular application lives on. Maybe it's the one that's closest to the user. Maybe I'm doing header-based routing. There's a number of ways that you can use it. But the point is that I have one IP, one Anycast IP that's fronting all of these clusters and all of these applications, because the ASM Gateway is the first hop once you get into the cluster, and then that routes you across all of your applications. And these need to run in a fleet controller separate from the application controller, because you can't have multiple controllers controlling the same load balancer. You would get into a race condition, so there has to be one hot at any moment in time. And for infrastructure, I just use Terraform, because that's, I feel like, where most of the customers that I work with are at. And so let's take a few minutes to talk about the ArgoCD mechanics, right? I'm pretty sure everyone here knows the concept of the centralized sort of hub and spoke model, but that's where I landed. To me, this was really the only way to manage multiple clusters with Argo right now. So I have on that fleet controller ArgoCD running, and then there's cluster secrets for each cluster that it's managing. And so it's sort of it turns into a push a little bit, but I think that's okay. And one call out here that's unique, we sort of helped shape as I was working through this example, is the team contributed to the controller, secrets controller for Argo clusters. And you can use this Connect Gateway service that we have, which allows you to, you don't have to embed a Kubernetes secret in your secret, or a Kubernetes token. You basically just give it a URL and point it at the Connect Gateway Google API, and then assign a workload identity to the pod that's running that service, so that it goes out and gets an OAuth token from the Google API service on the fly, as opposed to having to embed the certificate inside of the secret. So that's pretty nice. If you haven't checked that out, I'll share an article that walks through that in detail, but I'm using that here. And so I solved for it by using generators. I love this concept of application sets. It really makes, I think it makes the problem more approachable. And so I chose to use 2 generators in my application set. Oh, so I see a question of the clusters private or public. Either one. In my example that I've run right now, they're public, but I have a switch in the tool that I use to deploy the clusters, and you can make them private, and it works just fine. Which is another great reason why that Connect Gateway service works, because when you use Connect Gateway, you literally don't have to have internet access to the clusters to use that cred. You basically get a kube credential, and then we proxy it on your behalf, and you don't have to have line of sight to the control plane public or private IP. It's pretty great. Yeah. So I use 2 generators. I use the Git and cluster generator. And so I've got like a structure in my config sync where I've got a folder for my applications. And then I've labeled my cluster secrets appropriately, so that whenever I drop a new application in a folder, based on the labels that are applied to it, it will create an application for each cluster that's tagged correctly. And so this way, I don't have to keep on making these applications. I don't have to roll them on my own. I kind of set everything up so that it's watching in folders, and I'm really just adding subfolders to folders to make deployments kick off or add tooling and stuff like that. If anybody, if I need to stop for take any questions, I'm happy to as well. But yeah, so moving on. So day 0, this is kind of what I was talking about, where you're staging the fleet. So when you set up your environment, you're setting up you're enabling the fleet API, which doesn't cost anything, by the way. And you're turning on these services. Now each service does cost something, but you could do these things you could roll these things on your own if you feel like the cost is a burden and you want to manage your own software. You can write controllers for these too. But you turn on the MultiCluster Ingress service, the MultiCluster service, and the ASM Managed Control Plane Controller. And so these things are on. And now that they're on, whenever I add a cluster to the fleet, it's based on the config that the ArgoCD is syncing with for the fleet controller config, it will start to hydrate and actuate all of the YAMLs that are in that folder, which means that one of the things is a MultiCluster Ingress object, and that MultiCluster Inject Ingress object will then program the load balancer and the Kubernetes cluster to ensure that you've got a load balancer that's routing to this new cluster you just added. All right, so let's talked a lot. I have a little bit more to go through with slides, but I think maybe we'll stop for a second and we'll just take a look at what I've got. Yeah, you got a comment, Dan?
Yeah, there were
muted, bud.
couple of little questions people are asking. People are asking, are all these clusters private or publicly accessible? I think I know the answer, but
yeah. So for the demo, I have them for ease of demo magic. They're public, but there's no reason they can't be private. The tool that I used, it's another open source tool that I maintain called the GKE POC toolkit. You can use this tool. You just change a Boolean in the config that you pass the tool, and it will deploy everything in private clusters. So there's no limitation here to using public or private clusters. In fact, private cluster in GKE means that it's completely private. The nodes themselves don't have access to the internet unless you add some sort of route to the internet or give them an AT gateway. The traffic between the nodes and the control plane is going over private IP to a site of range that you assign, and the interactions you have with the control plane API are also over private IP, or you use the Connect Gateway, and the Connect Gateway does it over magic, without exposing the public IP.
Yes. So, and I think the only requirement is that as long as the ArgoCD hub, the main ArgoCD instance, is able to access the cluster. So you could have that all in a virtual private cloud,
Yeah, so all of these clusters in my demo, and I could just show you here, maybe this will be easier. So all these clusters that I have are in the same VPC. So one interesting thing, people don't realize this until they get into Google. I did it too because I came over from Microsoft. You try to engineer a VPC per region because that's what you know. With Google Cloud, VPCs are global, and so essentially what you typically use a VPC for in Azure and Amazon, you use a subnet for in Google Cloud. And so each of these clusters is in a different subnet, but it's all in the same VPC. You can see that right here.
Mm-hmm.
This is just default. I haven't deleted it, but you can see I have Argo demo VPC, one subnet, and then I have secondary ranges for pod and service siders for each.
Yeah, awesome. Okay.
Yeah.
So, and then the other question was what you meant by fungible cluster. And I think what you're saying is they're essentially disposable. You can A/B test between them, not necessarily split up the cluster into multiple components.
Yeah, exactly that. There's nothing special about any of my clusters. The specialness is in the config that I'm syncing. And so when I add a new cluster and I label it appropriately in the cluster secret, stuff just happens. And the stuff that happens in my use case usually takes about, 5 minutes or so. And then I have another live cluster. I'm sure that in real life, you might have some stateful workloads that make this a little more complicated. There may be some steps that have to happen, but Argo is actually one of the things that I found really awesome about Argo is this ability to use all these different kinds of hooks. So if you do have dependencies, that's one of the hardest problems to solve for, I think, in GitOps is when you have dependencies of objects upon each other. You can use dependencies in Argo so that you can require that certain things get deployed first, become fully functional before they move on. In fact, one of the issues I have here is with the Anthos service mesh. When it gets installed, there's an object that you install, that thing will report ready. But when that object gets installed, the Anthos service mesh controller reads it and then does work in the cluster. One of the things it does is install a mutating webhook. And so it's very possible. So ArgoCD would be like, okay, well, this object's ready, move on. But without that mutating webhook there, then you're not going to be able to inject any images into any of your sidecar proxies or your ingress gateway. So I had to create a job and I used the Argo webhook to have it check for that mutating webhook and then move forward. So
Nice.
You'll see that here when I add the cluster actually. So why don't I do that right now? Right now I have this Where Am I app, right? Oh, my kids, hey kids, come on, sorry. Right now I have this this Where Am I app, and what's useful with it is it just reports information about the pod that's serving the particular request. So you can see this one's going to central 1B, right? And if I keep on refreshing, basically traffic's going to that global load balancer I was talking about. It's getting routed to the ASM gateway that's in central 1B, which is then routing to the pod. So there's a couple of hops there. But I want to add an East Coast region. So I'm just going to run this quick script that's going to onboard an East Coast region. And then you'll see that this will start serving traffic from the East Coast. So let me do that real quick. Cluster add. That's yes. Oh, great. Doorbell's ringing. Kids are screaming. Nothing like work from home, folks. All right. So this is going to take a couple of seconds. Full disclosure, I've got the cluster baked. All that really did was add a secret. But the cluster deploys in GKE are about 5 minutes. If we had more time, I would just do a completely new cluster. Anyway, and so that's rolling. If we go into Argo CD, you can see now, if I, let me refresh, make sure that cluster added. There's an East cluster now, and you see that it's starting to roll configs out into those clusters. The first thing it's going to do, let's see, is install some dependencies. Sorry, I'm distracted because someone keeps on knocking on my door. One of the benefits of being at the entrance of your home. And then there's a rollout that's pending, and some configs that are for destination rules that are pending. There should be an ASM gateway that gets deployed. So sometimes it takes a couple of seconds, but once the ASM gateway comes up, I'll be able to show you that hook. So let's let this bake for a minute. And we could start to look through the other app that I have right now while that's going on. So I'm using this really sweet Rollouts demo app that some folks, some maintainers over with Argo. Actually, I'm not quite sure what the genesis of this app is, but it's very useful for showing rollouts. So we can get that canary rollout experience. So I have this running too. And I also have a remote Chrome. I'm using Chrome to remote into a Debian box on the West Coast. You can see here that when I curl that Where Am I endpoint from the West Coast, I'm getting a Western cluster because I have a West cluster and a Central cluster. And now if my rollouts, or if my ASM gateway gets deployed, then we'll be able to see it hit the East cluster. So let's go back in here. Okay, there we go. Stuff's still happening. Does take a little bit of time to work through all of these configs I just threw on the cluster. But what is interesting is this ASM gateway. And this is dependent on, there's a webhook. See this webhook job? That's what I was talking about earlier. So this job is going to run before the gateway itself gets deployed. And it passed. It happened really quick. And so now it's deploying the ASM gateways and the cluster. And we're getting there. Any questions on what's going on right now? I feel like I just went through that really fast.
Oh, so
while
far, so
still
good.
not actually having successfully hit an East Coast cluster yet, but it'll come. All right, we'll give it a second. Sometimes if you walk away, and immediately it'll start working. No, okay, we'll get back to that. So this is what just happened, right? So it takes a couple of minutes to hydrate all that config, but what happened was I just added this other cluster with the right label and the right secret, and a whole bunch of config just got installed on it. And so all of my applications that were running over in the West and Central are now getting bootstrapped onto the East. So if I had a third region here, you'd see it. And let's give it one more try. There we go. So now it's serving traffic from the East. Yay. So that's it. I mean, if you add 5 or 6 minutes to deploy the cluster, that's, I don't know, maybe, I don't know if anyone was timing me, maybe that's 10 minutes to get a hot cluster in a new region. It's not bad. So what's happening right now is I'm in the East Coast, right? So I live in Atlanta, Georgia, and I'm hitting the East Coast zone because that's the one that's closest to me. If I go back over to a West Coast, so it's just a VM running in the West Coast, you can see this one's still serving up traffic in the West. And so if one of these clusters were to break, or the application were to break, traffic would just proceed to send me to the next closest region. So it's really handy for HA. In fact, I can get a little crazy right now, and well, no, we got more things to talk about. I have a whole nother demo where I start chaos engineering all this stuff, and it works pretty great. But so moving on, right? We added a cluster. We've sort of talked about working through this idea that we need disposable clusters, or clusters without personality, maybe we'll call them, right? So you bring this cluster on and it's just like the other cluster. But what about this user story right here? We're shipping code. Our error budget's on the brink of causing a code freeze because we're doing all the proper SRE, SLI, and SLO stuff, measuring things and deciding. We need to get better at safely releasing changes, right? We're probably, but how can we do that? How can Argo help us do that? And how can GKE help us do that? Well, this is where Rollouts comes into play. I love this CRD. I love this idea of progressive releasing that you can define in the configuration. I think it's very intuitive and helpful. And a couple of quick callouts here that are specific to GKE. I am running a cluster analysis template. So this is the template that defines how I'm running a test in between each step. And I am calling this Prometheus endpoint, but this Prometheus endpoint is just a front end in my cluster for Prometheus. The back end is Google Cloud logging and monitoring. So we have all of our logging and monitoring now can be queried by PromQL at default. You just need to stick a front end in your cluster, make sure that you have the right permissions on that front end so it can query Monarch, our back end system. And then you could do things like grab Istio success rate based on response code without having to customize everything. It's pretty amazing. You should check it out if you have a chance. If you're using GKE, and you need to hit Prometheus metrics, you should definitely try this. But so the rollout allows us to step through, run some experiments and tests, and then pass or fail those tests and move on to the next wait. And so this is the rollout that I'm using for the canonical Argo official rollout demo, which I love. And it's working with Istio. You could say defined it, well, a virtual service, that's an Istio object. And so basically as it's doing this, it's adjusting the virtual service wait to start sending traffic to the new version of my app. And we're here, we may as well do the rollout demo. And of course, any excuse I have to show the amazing dance moves of Mr. Bill Gates, I will. Let's just take a minute to acknowledge that. Yeah. All right. So you can see here, I'm running the yellow version of my app. I love this app because if I want to start injecting errors, I can. If I want to start injecting latency, I can. And so I'm measuring errors or latency as the thing that needs to pass before going to the next step. I can just inject it here and show how it will fail back. I don't think I'm going to get that far because I want to save time for Q&A. But the last bit of the demo, let's just come back to my trusty shell here. Ooh, I hear noise upstairs. I wonder if the Yankees scored again. Anyone got the score of the game? Let's see, Fluster. So I am just running a script that's going to push a new version of the Argo app out with a new image tag, and the tag is just the color. And it is going to update my wave 1 clusters. So it's going to update my central and west clusters because I have a separate application set per wave. And this is my crutch, which is Control R, recursive searching. Okay, so the last time I ran this, it was yellow, and on 2, we're going to switch that to wave 1. And I don't know, let's make it purple. Purple, I spelled it right. Okay. It's going to do some things, then push that change up to Git. And you're not going to see it change here because I'm, again, getting routed to the East Coast. But if I pop into my West Coast cluster, it should start to step, and you should start to see purple squares. And we could check on this. I love the Argo UI. Y'all, this makes me so happy. I could just come in here and find the app that I want. And I have these separated by teams. So if I go under projects, I think it's team 1. Yeah. It hasn't. One thing I didn't do, I think, with this environment was you can make things move faster if you just have it, if you have GitHub in my case, notify Argo of every change as opposed to waiting for the poll. So it's probably waiting for the poll right now. But what'll happen is you'll see the east the west and central clusters. This rollout's going to change, and then it's going to start editing that virtual service. And then, you know what? I think maybe as this rolls out, because it does take some time, maybe we just do questions, and then I could keep this screen up and we could watch it do its magic. Does that sound okay? Does anybody have any questions or topics they want to bring up? No? Oh no, Cleveland scored. Yeah, I need to change the update interval, but. All right, so maybe let me ask, I'm going to ask a question. If you're not going to ask questions, I'm going to ask y'all questions. So what do you think about multi-tenant clusters? Like where I'd love to see feedback from the folks, from the attendees on how they feel about this idea of running multiple business units in the same fleet of clusters, or multiple applications from different teams in the same fleet of clusters. Is that something, do you feel like you're okay with handling all the security concerns with that, or would you prefer just to keep it simple and have a cluster tenancy model?
Well, it seems like this is really about the capabilities of multi-cluster ingress, right? So like one of the issues that we have, if you're using Argo hub and spoke model, people will submit multiple applications that will that will step over each other because they have the same name, for example. Is that an issue with ingress? Is that something where I need to have a separate team managing my ingress that's multi-cluster, just because there needs to be like, a pathway to make sure that people aren't stepping on the pathways that I want to provide?
Yeah, well, there's two things to that. One, multi-cluster ingress is, based on the ingress resource. And the ingress resource, for all the things that we love about it, is one pretty glaring flaw in that the front end and the back end are kind of married together in the same resource. So you can't really separate you couldn't give like a developer team access to sort of the routing side inside the cluster without also giving them access to creating public IPs essentially, right? And then you have to get into like cloud provider ways to prevent that from happening. The MultiCluster Ingress is great because it will give you the ability to distribute across a bunch of clusters. And the idea here is though that like all those services have the same name, the same service name. And so if you're deploying multiple services, then, sorry, if you're deploying the same service across multiple clusters, you're kind of buying into this service and namespace sameness. So you really got to be diligent about saying, you know what, I'm really going to buy into managing this centrally, and I'm not going to think about the clusters as unique clusters, but the pattern of clusters as a thing. And I think that's kind of my theory here. But one thing that's going to make this a lot more intuitive, I think, and I give it a lot better security model is this new Gateway API that Upstream released. So the Gateway API separates the front end from the back end. It kind of follows the Istio model so that you have routes and then you have basically gateways. And so the gateway is like the IP and the cert and all of the things that you want your network and security folks to manage. And then you could just give your developers the routes, and they don't have to have permissions to control the gateway at all. And we have a multi-cluster gateway implementation similar to MCI. It's not GA yet. This is all sort of new, but I think in the next, we're set to release GA multi-cluster gateway by the end of next half. And I think that's going to really help this idea of how you're managing that north-south boundary with your network across a cluster.
And these can all be managed using GitOps. I don't know if you do it in the UI or something. I can.
Yeah, so that's a good point. So if you look at the way I carved up my repo, you'll see that I have this multi-cluster controllers. That's just what I'm calling it. But this is the ArgoCD controller, and in that ArgoCD controller, which is just one cluster, there is it's actually identified as the multi-cluster ingress controller. So there's a controller outside the cluster that's watching for this resource, right? And I'm providing it a public IP, all the certs I need, and the service name on the back end. And it will then sync that across the load balancer, and combined with the other requirement, which is the multi-cluster service that identifies what those backend services should be. What this thing does is there's another service that goes out there and looks in all the other clusters to find services with the right name and adds them to the back end of the load balancer. And so the combination of these two things allows me to just, as long as I'm using service name sameness, I can add a cluster. If it has the right namespace and the right service name, it's just going to become part of the back end of that load balancer.
Yeah, and that supports like tags and stuff too. If I wanted to tag one staging and one prod or something like that, I could do that.
Yeah. I mean, now you're getting into the
just any kind of selector you write, right?
Right, exactly. And most of the time it's like, so with the canary stuff, I'm doing that with Istio, with ASM, same thing. And so I'm using Argo, and it's just updating the weight in the virtual service object. But the gateway, when the gateway spec replaces the multi-cluster ingress, you'll have the same control at the north-south boundary that you do with Istio. So you'll be able to start directing traffic upon ingress to the cluster based on a header, based on rate limiting. There's like a whole slew of features that we're setting up. Basically, almost anything you could do with Envoy is going to start to become available on GKE, because we replaced all of our internal front end servers with Envoy.
Oh, really? So
yeah, we're exposing them.
Can I throw WASM onto that? If I have some like WASM WebAssembly modules I want to throw on there?
No.
Not yet.
Not yet. Yeah.
Okay.
We support it in ASM at your own risk. So if you break stuff, it's on you. But
so one of the questions that people had is, and I have my own answer to this, but someone was asking if this is what vCluster is really designed to solve, and why would someone pick a multi-cluster ingress with multiple clusters over something like a vCluster? And like I said, I have my own thoughts on that, but I would love to hear what you think.
Yeah, so I think it depends on what you think the tenancy model should be. I mean, are you concerned with multiple business units in the same cluster? I think if you're using, and I could be wrong, I'm not quite as read up on vCluster as I should be, but I feel like if you're using vCluster, it's more about tenancy because it's the same CPU and resources. So there's still going to be contention for resources, right? Because you're just stamping out virtual clusters on top of one cluster. And my other thing is, I think I don't want to like put my foot in my mouth, but to me, I'm like, if I have the cloud, it's one API call away for me to get a cluster. I don't know that I need a virtual cluster on top of a cluster. I have this API. Can I please have a cluster? Can I set it up with cluster auto scaling? Can you pick the right node pool size for me? Yes. Okay. We have all these great features that try to remove the management of the cluster away from you. In fact, the newest version of GKE that we have has an autopilot mode in which you don't have to manage nodes at all, and you pay and get an SLA on the pod. So you pay for the pod resources. So we're trying to move, we're trying to get out of the operating system aware business with clusters and move towards more application focus.
Yeah, one pattern that I've seen emerging with the use of stuff like this is basically, I mean, philosophically, we all understand that, hey, container services, nodes, I want to treat these things like cattle, not pets. I don't want them to be special. I throw them away, whatever. But for most of us, clusters are pets. Clusters are special. And we think of them that way. So this is one way that an emerging pattern I've seen is companies going with a strategy where when they have updates to their services, they actually just stamp a new cluster out, do the routing, pull it out for their blue-green deployment, and then they have a hot spare, for some period of time where they can switch back. And that makes sense when you have a certain level of complexity of service interdependency within the cluster. And that could actually be an easier option. And you can still do it with cluster API, plus GKE, and you're rocking and rolling. It's all completely declarative, and it's all GitOps, operated. So, but yeah, the multi-tenancy aspect of vCluster is usually why people do it, because they want to have some separate permissions thing. In this case, we're actually kind of bringing services across different places. And my other question, and I'm sorry to pull you so much onto MultiCluster Ingress, but how does that work with geo affinity? So for example, do I have to send everybody through the load balancer in Missouri to get to a cluster that might be in France? And I would actually prefer people go directly there.
No, so the magic of Google Cloud Load Balancing is that you get an Anycast IP. It's the same, like you're using the same front end that you're using if you use Google search, right? You're gonna come into our POPs, which we have all over the place, come into the closest location to you, and then get routed to the Google backend that's closest to that location. And then when the gateway spec gets released, you'll have a ton of control beyond just least latent path. So no, that's the beauty of it, is you don't, if your application were truly hot, active, and you figured out like how to beat CAP theorem on the back end with data, you could just turn on a Google Cloud Load Balancer and have that IP hang off the internet, and everybody will go to the thing that's closest to them. You'll ingress into Google at the POP that's closest to you. And then the next question out of most of the people I deal with who are regulated is, well, we don't really want that all the time. It's configurable. So you can, it's per ingress object. So if you only have 3 clusters in 3 different regions, you may ingress to a POP in Europe, let's say, but you're still only going to get routed to the clusters that are actual backends. And then the other thing is, we've acknowledged that not everybody's ready for Anycast IP mode, and we've released regional versions of the load balancer that will work as well.
I think it's actually the same basic load balancer that's running like the load balancer for google.com and youtube.com. I think you referenced that.
Yeah.
I used to joke that I use GKE because my mom's blog gets the same load balancer as YouTube, and that just makes me feel warm and fuzzy.
That's very true. It's very true. But
We
so
had
like
another.
one of the other things that you had said that sort of caught my ears were you were talking about this idea of onboarding clusters when there's change. I love this. So there's going to be people on my team that get angry at me, but like if it were me and it were my platform, I wouldn't be upgrading clusters at all. And I would use things like these features I just showed you to just put in a new cluster, shift work to it, make sure everything's working okay, and then shut down the old one. Like that's the same way, because in my opinion, you can't catch everything when Kubernetes API changes unless you're really, really good at your pipelines and catching all this stuff, and all of your environments are ahead of the one that's in production. It's hard. Even after all that, you might get bit by something. But this idea of a fungible cluster means that everything, like each cluster is the same. There should be no variance really. And adding a new cluster with a new version can be as simple as the same thing I just did, except you just pass in a new flag for the GKE version with your infrastructure as code.
Yeah, and when you're generating, this isn't something you really talked about, or I didn't notice. When you're generating a new cluster, are you doing this with Cluster API and Argo CD, or you just wanted to say, hey, that's not part of the layer that we're talking about today, I just created it manually or whatever?
Yeah, so I have this other tool. I have a bash script that calls this other tool that I maintain. It's a Go CLI that's wrapped around Terraform. And so I have these configs that I pass it. And then if I want to add a cluster, I just add a cluster.
Okay.
And it runs an update, not necessarily because it's Terraform. So it's not going to destroy all the other stuff that I have, and it'll just add a cluster. And so that's
maybe,
one of the
maybe next time you come back, you will have upgraded it to Cluster API and have it all sitting in Argo CD. So it's fully GitOps, up to the,
that's a part that, I mean, that conversation's coming up a lot right now, is this idea to use KRM, Kubernetes resource model, sorry, to deploy everything. I haven't read as much about, like, shamefully, I haven't gotten to that part of Argo yet. Does it work with, is there any dependency on like control plane or control plane IO, or is it completely independent?
No, independent, I believe. So Cluster API, you basically create, you create a secret with your GCP credentials that allow you to provision things. And then you just drop in you have as part of an application in Argo CD, your YAML for the cluster that you want, and it will spin it up and report on it. And if it gets modified, it'll report that the app is out of sync in Argo CD, and it can re-update it, etc. So
interesting. And it's a GKE cluster.
Yeah, you can do it with GKE, with EKS, with VMware.
All right, well, I got some homework now. I haven't gone down that road yet. But yeah, there is.
Yeah, worth checking out.
I'm a little hesitant on the infrastructure side. But I feel like we always feel this way when we haven't done it yet, and I just haven't done that yet. So let me do it first before I say anything about it.
There was another question, and this one's more general Argo, so I'm happy to take it too if you don't want it. But someone is saying, I see people talking about app of apps versus application sets. Which one is better?
I mean, two different purposes. App of apps to me is like, how am I going to bootstrap all of this great Argo stuff with Argo? Application sets are, how do I manage a lot of different configuration as dryly as possible without repeating myself? And so I used application sets for everything that I could use application sets for. And that's what you see these, I call them generators, but I have one for just, they're all watching different folders and doing stuff based on what gets added to the folders. But that's my answer. You go for it too.
Good moment to plug the GitOps certification with Argo that we offer, because it'll actually teach you how to do both, and it becomes pretty clear the differences when you get hands-on. But it's exactly what you said. Application sets are for generating applications in a programmatic way. And that could be based on when somebody opens a pull request, it can automatically generate an application based on all of the Git repos that are connected, based on all of the Git providers that are connected, based on the folder structure that can generate applications. Whereas an app of apps is more like, I have an application that has all of these components and these different apps that are part of it. I want them to be brought up even in a certain order, etc. I could make that an app of apps. Then I have one thing I installed and installs all the base stuff underneath it. And spoiler alert, you can use them together. So you can use an application set that generates app of apps. And you can also have app of apps that reference application sets. So you can get pretty funky with it if you want.
Yeah, I know we're up on time, but real quick, just to nail it home with an example, if you look at this, what would be the most interesting one? App cluster tooling, right? So I've got this set up using two generators. This Git generator is watching this folder in this Git repo for all the subfolders in that Git repo, and then it's matching on using a cluster generator on a particular label that's applied to the secret. So it's going to look in here. All I have to do then is come into this app config thing. I don't know, drop a new folder, put some YAML in it, push it to the repo, and then this application set's going to generate applications for that new thing that I put in there based on whatever label selector that I decided, which is that's really cool, man. So like when I'm adding new apps to teams, I'm just dropping new folders in these subfolders, and it just all kind of goes.
It likely won't be in Argo 2.6, but in Argo 2.7, we may be able to, they're working on it right now, the ability to actually have rollouts across application sets. So you can say, when a new change is introduced, do it to 30% of my apps in the application set and so on. So it's kind of a different level of canary release going on. But anyway, we'll see. But anyway, I know we're at time. We've taken a bunch of questions. Hopefully the audience was able to get what they wanted. Nick, any last things to plug before we close?
I'm going to be at KubeCon. I don't know if anyone here will be. If you're going to KubeCon, feel free to hit me up. I'm going to be at the booth a bunch. I'm doing some lightning talks. If you want to meet with a GKE PM, just let me know. I can help you meet with one of my peers. We're just there to interact with our users and try to help them as much as we possibly can. So yeah, look me up. My Twitter stuff is somewhere, LinkedIn, whatever you need, you can get a hold of me.
Perfect. Well, you heard the man. Hit up Nick at KubeCon. I'll be there as well. Sharon will be there. Go to the Google Cloud booth. Go to the CodeFresh booth. We'll be at the Argo booth. We'll be all over the place. There'll be lots of talks going on. And don't forget to share your favorite talks. Share the stuff that you enjoyed from this session. And if you'd like to hear from a different speaker or certain topics, send that feedback in. We love to have that kind of stuff as we're building the program. And with that, we'll sign off. Thank you, everybody, so much for joining. Take care.
Take it easy.